Hi everyone, my name is Thomas Kim. In this episode, we will learn the most important yet least understood concept in C++ language. That is, exception-safe coding practice. We will improve our permutation algorithm from this previous session. Please click this link to download our previous source code. If you haven't watched this video, please watch it, because this session continues from my previous video, Enumerate Permutation Theory 0, Theory 1. We will fix some flaws in this algorithm. I believe exception is very important feature in C++ language. This session is to prepare for my next session about for each permutation and backtracking. Very important algorithm in modern programming. So to implement for each permutation an algorithm, we need to understand what is exception-safe coding practice. Okay, let's get started. This is previous source code. I will add a new file. Exception safe cpp. So I created a file exception safe cpp. I will copy the whole part, Ctrl A, paste it here. Now I close test permun cpp. We prepared test permun cpp in our previous episode. If you haven't downloaded, please download it and you can copy this file. Now this is new file. First, we will introduce namespace. I would say permu. Then I block up to this code like this. Then permu like this. I modified and I will indent a little bit up to this point. And I will change a little bit. Instead of doing this, I will delete element, and instead I will introduce template. Type name, element type, like this. Then I have to modify like this. And here we also introduce template, type name, element type. Then I paste like this, okay? Then we can actually do like this. It's much cleaner. Then here we also provide template, type name, element type we introduced. Then we have to paste like this. Also here. Also here. We are modifying our previous code. Now scroll down. We also have to modify like this. Element type. Then copy this, paste, and paste. Then scroll down. Then we will say int. I made a few changes and I will remove this part. Now let's build if it works. I missed here, closing. CL, we are using Microsoft compiler. EHSC, exception safe cpp FEMEXE 31 31, it should be element type. Like this. Try again. Okay, it works as before, as in previous session. The problem in this case is this block, this code. We in place back, we push back, then we pop back. In between this line of code, from line 31, line 51, if exception is thrown somewhere in this block, this program crashes or does not work properly. Okay? If an exception is thrown before our pop back is reached, this program does not work properly. We need to handle this issue in exception safe manner. This is really important. There is two ways to handle this. Actually, there are many ways. I will first try simple way. Include memory. I am trying to handle this in a simple way. This is the first way. So after in place back, we have to make sure our pop back is called even if exception is thrown. So here I introduce a lambda like this, auto create cleanup. There are several ways, but this is just one method. Auto. Please note that R should be modifiable. So I say obj. We are creating a lambda here like this. Then we create a simple struct. I created a simple struct. Don't forget semicolon here. Also don't forget semicolon here. Okay. Then here using obj t decl type obj. We are getting obj through lambda parameter like this. Then we declare an object type. Okay. Then we can remove std. Sorry, I need to have type trace. Here it should be L value reference, so it doesn't matter. Here using obj t mobj. This is a member. This is a member of this class. Since this is reference, it will be reference. So this is reference type. Sorry, I remove this. This is actually reference. If you want to make it clear, then we can do it like this. Remove reference t decl type. Okay, we remove the reference from this type. Then we can say like this. Remove. Okay, this is more clear. Then I create cleanup. Please. Auto. Oh. Okay. Then we initialize obj. Oh, like this. This is constructor, default constructor. Then we need destructor. We need destructor. In destructor, we call O popback. Like this. We will put some message here, std, or just to say cout. Wow. Popping back. Okay, I created a simple message just for testing purpose. This message will be displayed when this part of code is executed. Then here, please note that we are inside of lambda closure. Then we return cleanup. Please, we are passing this object as constructor parameter, this parameter here. So we passed one argument like this. We can actually pass as the lambda capture here also. If we have more complex code, then we can put more parameters. Now using this lambda, I will make it shrink it like this. We can create an object or clean block. We are create cleanup. Now we are passing R like this. So when this returns, this lambda returns an instance of this cleanup please, and this R is passed as a parameter to lambda like this, and this parameter is passed back to this inner class, and an object of this inner class is returned. So this object is local. Cleanup, clean block is a local instance of struct cleanup please. Okay, this is cleanup please. So when this local block exists here, then this pop-up is called. This pop-up is called. As pop-up is called. So we don't need this. We fixed like this. Now let's try it if this message is properly popping up. Let's see. This is exception safe. Here we compile again. 52. Sorry, we cannot pass like this. We have to provide this type like this. Okay. O is undeclared identifier. Where is O? 57. It should be MB. Like this. Try again. Okay, CLS. We can see it each time it is leaving block. We can see wow popping back. This message is displayed. Okay, so it is working properly. Now I disable it and build again. It works properly. Now I will shrink it, this part. So whatever happens in this block, so in this else block, what kind of exception is thrown, as pop-up is called properly. So we can now throw in this function. Another way, we can create a simple way like this. Now I create another way. This is also very viable. This is important. When we create very complex algorithm, then this method is prepared. But for simple case, we can do like this. Or cleanup block. Well, you can say just pop up. I'll pop up. Pop back. Creating another lambda. Or we can just ignore this. Instead, I will use lambda R like this. We captured R as reference. This is R, and we need one parameter. This is actually, we can ignore this. Now R pop back. See out. Wow, popping again. and L. Okay, I created a lambda. Don't forget semicolon here. We defined a lambda. Then we can do like this. Using R type T, I'm creating this R type. We actually know this type, but if we don't know this type, we can do like this. We can define DECL type, R type. Okay, but this is not enough. We need to remove std, we need to remove reference. Okay, sorry, DECL type, we have to remove reference like this. Then after removing this reference, std unique ptr R type T cleanup. We are creating an instance of a unique ptr. Then we actually send the unique ptr like this, R. We are passing R. Okay. Then we have to provide here cleanup code. Please note that DECL type, this type, like this. We have to provide the type of this lambda. Then R pop up, pop back, like this. Cleanup is also local scope. Cleanup is also a local variable. When this unique ptr goes out of this scope, this else block, then it calls this cleanup function, this lambda function, and this lambda function calls R pop back. So this function works the same way as before. Now try this. Okay, it works perfectly. So I presented two methods to create exception-safe programming method in C++ language. The first method is more advanced, and we need this kind of programming sometimes when the application is very complex. We need to have more advanced feature. We can use this method. For simple method, this is also very good method. But in this case, you probably need to understand how to use unique ptr. I made 4 videos about unique ptr in my YouTube channel. Please refer to those videos about unique ptr if you need to. In next session, we will create for each permutation algorithm for backtracking. This permutation algorithm is actually very important. Please subscribe to my YouTube channel. Thank you for watching.